Welcome to the Ring Boys, where we explore the forces and discoveries that make Saturn one of the most fascinating worlds in our solar system.
I'm Owen Weinbarger, and in this episode, we'll travel through Saturn's spectacular ring system and the spacecraft that revealed its secrets.
I'm Michael, and together we'll journey from the tiny moons that guard Saturn's rings to the Cassini spacecraft that explored the planet up close, back to the extraordinary Galileo mission that paved the way for it all.
Let's begin with the cosmic guardians themselves, Saturn's Shephard moons. When most people think of Saturn, they think it's beautiful, shimmering rings, but few realize that those rings stay in place thanks to a handful of tiny moons known as Shephard moons. These moons orbit just inside or outside Saturn's ring edges. Their gravity tugs and pulls on ring particles, keeping the rings sharply defined like cosmic herders guarding flocks of icy dust. Two of the most famous are Prometheus and Pandora, which orbit near the narrow F rings. Cassini showed us that they constantly sculpt and twist the rings, pulling streamers of material as they pass. Another moon, Pan, orbits inside the ink gap, carving out a perfect path as it goes. It even has a strange ravioli-shaped ridge from collecting ring material over time. Shepherd moons don't just shape rings, they teach us how gravity organizes chaos. By studying them, scientists can model how planets and moons formed billions of years ago from swirling disks of gas and dust. The Cassini spacecraft gave us our best look yet at these interactions. Through time-lapse images, Cassini revealed waves and ripples spreading across the rings like a ripple in a pond after a pebble's dropped in. It's a powerful reminder that even the smallest bodies, some no more than a few dozen kilometers wide, can play a huge role in shaping an entire planetary system. But to truly understand how these moons and rings behave, scientists need to get closer than ever before. That's where one of NASA's greatest explorers came in, the Cassini mission.
The Cassini mission was one of the most ambitious projects in the history of space exploration. Launched in 1997, it traveled nearly a billion miles before finally arriving at Saturn in 2004. The mission was a collaboration between NASA, the European Space Agency, and the Italian Space Agency. Cassini was actually two spacecraft in one. The Cassini orbiter, which would circle Saturn for 13 years, and the Huygens probe, which would land on Titan, Saturn's largest moon. Cassini's discoveries changed everything we thought we know about Saturn. On Titan, the Huygens probe revealed a world with mountains, lakes, and rivers, but not of water. Instead, they were made of liquid methane and ethane. Titan's thick orange atmosphere turned out to be rich in organic molecules, making it one of the most Earth-like worlds we've ever found. Then there was Enceladus, a small icy moon that stunned scientists when Cassini found geyser-like plumes shooting water vapor and ice into space. Those plumes came from a liquid ocean beneath the surface, one that might even host microbial life. Cassini also gave us the most detailed images of Saturn's rings and the atmosphere, capturing swirling storms, massive hurricanes at the poles, and the mysterious hexagon-shaped jet stream at the planet's north pole. In 2017, after 13 years orbiting Saturn, Cassini's fuel began to run low. To protect moons like Titan and Enceladus from contamination, NASA commanded the spacecraft to dive into Saturn's atmosphere in a fiery finale they called the Grand Finale. During its final orbits, Cassini flew directly between Saturn and its rings, something no spacecraft had ever done, gathering the most detailed data we've ever had. Cassini may be gone, but its discoveries continue to inspire. It showed us oceans beneath ice, rain made of methane, and a planet alive with storms and color. But none of this would have been possible without the mission that came before, the one that taught NASA how to explore the outer solar system in the first place. That mission was Galileo.
Long before Cassini reached Saturn, another spacecraft was testing the limits of a human exploration, which is NASA's Galileo mission. Launched in October 1989 aboard the Space Shuttle Atlantis, Galileo was sent to study Jupiter, but along the way it helped lay the foundation for how we explore all gas giants, including Saturn. Galileo's route wasn't straightforward. It took advantage of gravity assist from Venus and Earth to build up enough speed to reach the outer solar system, a navigation technique later used by Cassini on his journey to Saturn. Those early maneuvers proved that long-distance missions could use planetary gravity like a slingshot, saving fuel and time. Once it reached Jupiter, Galileo became the first spacecraft to orbit a gas giant to send a probe into its atmosphere. It studied Jupiter's swirling clouds, rings, and magnetic field, data that helped scientists prepare for what Cassini would face around Saturn. The radiation readings and mechanical challenges Galileo endured directly shaped the way engineers built Cassini's protective systems and instruments. Many of Cassini's sensors were improved versions of those first tested on Galileo. Galileo also showed that long-term exploration of distant worlds was really possible. It survived 8 years orbiting Jupiter and made astonishing discoveries about its moons, including volcanoes on Io and a substance ocean on Europa. Those findings inspired Cassini's mission goals to look for similar features on Ecladius and Titan. When Galileo's mission ended in 2003, NASA intentionally sent it plunging into Jupiter's atmosphere to prevent contaminating potential habitable moons. 14 years later, Cassini would meet the same fate at Saturn, ending its mission the same way its predecessor had. Two spacecraft, decades apart, both diving into the planets they studied, both protecting next generation of exploration.